Hi everybody, I want to help you out with section 8.1 a little bit more with this geometric mean stuff. So a couple things I want you to look at. When you have the geometric mean altitude theorem, when you look at this, what this means is if you set up all these proportional triangles in here, because we know there's three, you would get that x over h, based on what you see here, equals h over y. And you could cross multiply and get h squared equals x times y and take the square root of both. Or you could just remember the altitude going from a vertex to the hypotenuse. See how it divides this into two sections. So this altitude is equal to the square root of the product of those two segments. Just a little shortcut for you, Owen. And then there's also this other one down here, this geometric leg theorem. It's very similar. But what this deals with is the legs of these big triangles here. So it's either A or B. So basically, you could set up this proportion of this leg, which is this hypotenuse of the small one, over x is equal to, looking at the big one now, x plus y, so segment AB, which is just x plus y, over B, which leads you to then start seeing that, hey, this leg is equal to the product of the smaller leg, this segment that's adjacent, not necessarily smaller, sorry about that, but it's adjacent to the leg you're looking for. So the leg adjacent times the big leg. So you're finding the geometric mean between the leg adjacent to the leg you're looking for times that hypotenuse, that whole thing in the big triangle. So you could use that, and then again, if you were doing A, if you're looking for A, then you're finding the geometric mean between y and x plus y. So two little shortcuts, and I'm actually going to talk you through a problem here, which is number 30 on the page that we did for our homework. So here's what we're given. And yes, it's messy, and I have actually some answers written in here. Sorry about that. But first thing I want you to do, looking at what you see here, ignore that and ignore that. Use Pythagorean theorem whenever you can. So the first thing I would do is find x, because you knew this side length and you were given this side length. So find that hypotenuse. So again, you simplify that, and remember that's 3 square root of 2 times 3 square root of 2, which becomes 3 times 3, which is 9, times square root of 4, which is 2. So that's how I'm getting 18 when I simplify that. Square root of 2 times square root of 2 is square root of 4, which is 2. So x squared is the square root of 20, which of course we simplify, which is how we get that answer. So now I would use the geometric mean altitude theorem, or just altitude theorem, and solve for, well, I would apply that to solve for z. So looking at this, because this isn't a leg, z is not a leg of this big triangle. So I'm going to use the altitude theorem where I know that this altitude is equal to this little segment times this little segment, and you take the square root. So then that just becomes an equation. So I have the square root of 2 equals 3 square root of 2 times your z. So with that, once I had that equation, I had z by itself equals this, this square root right here. So then I squared both sides to get rid of that radical right here. So then when you square both sides, this gets rid of that. And when you square this side, it actually gets rid of that radical as well, which is awesome. So now we have 2 equals 3 square root of 2 times z, divide both sides by 3 square root of 2. So I want you guys to look at how I simplify this. So I now have 2 over 3 square root of 2 equals z. Rationalizing the denominator, so getting rid of that radical, multiply by square root of 2 over square root of 2. You end up with 2 times square root of 2 over 3 times square root of 2 times square root of 2, which is square root of 4. So 3 times 2 will give you 6, and then you reduce right there. So you have 2 square root of 2 over 3 is your z. And I know these are ugly, but these are just radicals. I want you to make sure you know how to find this radical value. And then third, you can find y. Again, looking at this picture. So here's y. So we have z, we have x. Me personally, I would probably just naturally go to square root or Pythagorean theorem using those two side lengths, which I did right here if you want to have a look at that. And again, there's a lot of simplifying with radicals, and I really want you to be comfortable with that. Or you could also apply this leg theorem. So if we're looking for y, we know y is equal to the geometric mean of z times this whole segment. So you'd have to combine those which requires finding a common denominator, which is what I did over here. If you want to look at that, I found a common denominator of 3. So it became square root of 2 over 3 plus 9 square root of 2 over 3. Square root of 2 plus 9 square root of 2. Those are like terms. That's like adding x plus 9x is 10x. So this now is 10 square root of 2 all over 3. So I just found the geometric mean then of that segment z, which is square root of 2 over 3, times the whole segment, which is 10 square root of 2 over 3, and simplified from there. And yes, you have radicals and radicals, but when you multiply right there, notice they're identical. It actually gets rid of them. So I really hope this helps because I want you to feel a little bit more comfortable than I feel like we did today in class. So I will see you on Monday and have an awesome weekend.